All right, so welcome back. We're gonna go ahead and talk about t-tests for individual predictors in the context of multiple regression now. And so remember, this overall f-test is just testing to see if any of our predictors are associated with the response, but it doesn't really tell us much more than that. We'll get a lot more specific information from these individual t-tests. And so, like usual, there's kind of a review here about what we did in simple linear regression, just so that it's kind of there. In multiple regression, we're going to see how this differentiates from the overall f-test in multiple regression. And so what we're testing for here is whether an individual predictor, x, so you might think just we've been working with age, so if age is associated with house price after we account for the effects of the other predictors. So after we account for the effects of house size and lot size. Our null hypothesis is just going to be that the slope coefficient or the slope parameter for the ith predictor, so if the I subscript is confusing, just think about one predictor, or in this case maybe age. And so our null model is going to be a model with all of the predictors except for the ith predictor. All right, so this is just a kind of general way to write it. Again, with an actual example, it might be easier if you don't really like the subscripts. Just think about the model, the null model as being the model with all of your predictors except for the one that you're testing. So in this case, our null model would be a model with lot size and house size, but not with age. The alternative hypothesis is that that parameter is not equal to 0. And so the alternative model, you could probably guess, is just a model that has everything in it. All right, so in words, the null model is that predictor I is not associated with the response after accounting for the effects of other predictors. The alternative is that the ith predictor is associated with the response after accounting for the effects of all the other predictors. Actually doing the test is the same exact thing as what we did in simple linear regression, except now we're going to use n minus p as our degrees of freedom instead of n minus 2. The conclusion is the same as it was in simple linear regression, except now we have this extra part that's after accounting for all of the effects of the other predictors in the model. And so, for example, for age, for age, we see this p-value of 0.0007 about. And so the p-value is again given in this fourth column. And so our conclusion for a hypothesis test for age would be that there is a strong evidence for an association between age and price of homes. For being more specific, of homes in northern New York, after accounting for the effects of house size and lot size. And then we could give our estimate for age, which I'm pulling from this previous table just in this row. Our t also in that row, and our p-value. Okay, so that's, I think, not super surprising that in general we're seeing strong evidence that houses that are older tend to have lower price, as we see in the negative slope estimate. Um, but if you go back and look at this table, you might find something at least somewhat surprising in that the p-value for lot size isn't actually small. It's pretty big. And so we're finding that there's no evidence that lot size and house price are associated after we account for the effects of house size and age. I think intuitively we would think that lot size and house price would be associated just on its own. And so what we'll pick up on next is why this p-value actually might be so large. Um, and we'll end up looking at another example that should make that even kind of more clear. And yeah, and so we'll delve into some examples for multiple regression that I think will end up being pretty cool because we'll see some seemingly contradictory things that we could hopefully reason through a little bit. And so that's where we're headed next. As always, definitely let me know if you have any questions.